Hi, everyone. This is Mr. Walter from Walled Lake Western. I want to talk to you just briefly about the law of reflection and kind of give a better explanation of what it is. Well, look at my drawing here. What we've got is we've got a barrier here, okay, that's going to reflect, okay, or allow sound waves to bounce off of it, all right? And what we got here, these lines right here going straight across, these are our sound waves coming in. Now, a lot of times it's easier to draw the sound waves as a single straight line. That's why I drew this right here, this arrow, if you will, coming in here. And what we're gonna do is we're gonna call that the incident ray. Incident ray, okay? It's just basically an arrow that lets us represent the sound waves coming in, all right? Now, when it hits this barrier, it's going to bounce off and head out this way. And here's our sound waves heading out. And we're going to draw a reflected ray that's going to represent those sound waves bouncing off. Now, here's what's unique about this. When it hits this barrier right here, what I did is I drew a dotted line that's perpendicular to the barrier. Okay, it's 90 degrees to the barrier right there. All right. Now, with this incident ray, and this is one of the reasons why we draw a straight line arrow to help us out with this, from this incident ray to this dotted line right here, that makes an angle. All right, there's an angle there. And we use a symbol called theta. It's basically just a circle with a line through it. It's a variable that represents angles a lot of times. All right, we're gonna call this the angle of incidence for the incident ray. Incident means to hit. Okay, so this ray is coming in and gonna hit this barrier, all right? And it's gonna make this angle right here with this dotted line, all right? Now, here's the unique part. When this reflected ray bounces out, it also makes an angle to that dotted line. We call that the angle of reflection, all right? Now, here's where the law of reflection kicks in. This angle of incidence equals the angle of reflection. It's a law, so it's always the case, okay? Now, right now, we're just dealing with sound waves, and you'll talk more about this when you get the light waves and a lot more examples of it. But restate the law here again. Angle of incidence is equal to angle of reflection, okay, like this. Let me give you an example of sound waves and reflection here, okay? Let's pretend we're at an old movie theater, all right? Now, old movie theaters, when you sit here, here's a screen right here, and here's your rows of seating like such, okay? The sound is emanating from the screen or up there by the speakers, all right? Now, in the old days, what they would do is it had brick walls all around. Well, that didn't last long because there would be what's called reverberation. That's when you're getting a lot of repeated sounds over and over, kind of like a repeated echo over and over throughout where you're sitting. And it was difficult to hear. So what they did is they put curtains up, okay, like such, all around, all right, the seating area. Now, what the curtains did is it prevented the reflected sound waves. So when these sound waves came over and hit this curtain, they'd be absorbed into the curtain, okay, rather than reflected. And it cut down on the reverberation, and you can actually hear much clearer and much better, all right, the sound waves that are just coming out to the crowd, okay? Nowadays, they have different things like surround sound and things like that that create more waves and things like that help you out to hear better, all right? So that's just one example. There's more in the presentation. Check them out. Bye for now.